In the previous chapter, we learned about how clouds are formed, right? When warm, moist air near the surface of the earth is pushed up, it cools down and can't hold as much water, and that water condenses as clouds. Okay, but not all clouds look the same. I'm sure you've looked outside and noticed that sometimes clouds look different from each other. So we're going to talk about some different types of clouds. Okay. Clouds also have information for you about what type of weather is coming, because different types of clouds are formed in different weather conditions and they come in front of certain types of weather. Okay, so cirrus clouds are these thin, wispy clouds. They're made mostly of ice crystals, and they're found very, very high up in the sky, which is why they're mostly ice crystals, because it's very cold up there. Okay, so if you have ever looked outside on a nice sort of sunny day and seen way up in the sky these really thin, wispy looking sort of clouds, those are cirrus clouds. Okay, they're very thin, which means it's very easy for winds to blow them along, and as a result, they are way out ahead of most weather because they're really easy to move. So winds that are coming from weather blow them way out in front of it. So these might be your sort of first telltale signs that weather is on its way, but they're going to come quite a ways in advance of that weather because of how quickly and easily they move. If you're looking at the picture on the right side of your notes, you can see cirrus clouds labeled up there in the top left corner. Okay, that's kind of what they look like most of the time. Next, we're going to talk about stratus clouds. Okay, stratus clouds are more middle to low-lying clouds. Okay, they are usually flat. So people talk about them as being like a sheet. So if you've ever looked at the sky and thought it just looks like one flat sheet of clouds, you were likely looking at stratus clouds. Okay? There's a couple of forms. Alto stratus clouds refers to clouds that are stratus that are sort of mid-level or higher. So they're not as high up as cirrus clouds, but they're also not super close to the ground. They're sort of in that mid-level. Okay? So they are also usually thin, which means that you can kind of see things through them. So if you've seen flat bands of clouds and you can see the sun or the moon through them, like you can see where it's at in the sky and there's like a general glow, that was probably alto stratus clouds. Okay, these come after cirrus clouds, so they're a little closer to the weather, but they usually do still come well before the storm really starts going. Then there are nimbostratus clouds that are dark gray and flat and sheet-like, and you can't see through them, and these usually bring precipitation with them. So if you've ever been outside and there's low to the ground gray, dark gray clouds that have snow or rain or sleet coming out of them, those are nimbostratus clouds. So if you look at that picture that's alongside on the right side of your notes, you can see in the sort of middle on the left, there's the alto stratus clouds. So those are those mid-level clouds, and they are thin and kind of easier to see through, but they still form a flat sheet. And you look down, you can see the dark gray blob of the nimbostratus clouds, and then just the regular stratus clouds under there that are just low-lying flat clouds. Next, we're going to talk about cumulus clouds. Cumulus clouds are puffy clouds. So these are the kind that you've probably been drawing on your pictures since you were in elementary school, and the kind of clouds you think about when somebody says clouds, right? Those big, puffy, pretty white ones that sit in the sky are cumulus clouds. Okay? They take a while to form, and they take several different forms as well. So just like we had normal stratus clouds and then we had alto stratus and nimbostratus clouds, there's different types of cumulus clouds as well. Okay, there are alto cumulus. So you'll notice that some of these have the same words on the front of them. Alto is a word we use to indicate that it's mid-level, so it's in the sort of middle of the sky range. It's not low, it's not high, it's middle. So Altocumulus are these small heaped up clouds that form in middle altitudes, and they're formed when warm air is pushed up by approaching cold air. So if you've ever seen these bands of puffy clouds where there's a whole bunch of puffy clouds that are all coming together, those are altocumulus clouds, and they indicate that a storm is approaching. So remember, we had high cirrus clouds that come way ahead, and then the lower lying sort of altostratus clouds that come after that. And then we get these bands of puffy altocumulus clouds. Those are indicating here comes the storm. Okay? Weather is on its way. And then we also have what are called cumulonimbus clouds. So you may remember that prefix nimbo from nimbostratus. This is a word we use to indicate that it has to do with some serious weather coming your way. They're going to drop precipitation on you. So cumulonimbus clouds have a low-lying gray base, and they are huge. They stretch from the very bottom of where clouds start to form all the way to the very top of where clouds stop being able to form. They're large and tall, and they have that characteristic anvil shape where it sort of pokes out at the top and bottom and curves in between them. We call that an anvil shape. And they bring heavy precipitation, like heavy rain, heavy snow, hail, and they bring thunderstorms. Okay? So if you're looking at your picture there, you can see just sort of regular cumulus clouds, and then you can see along the right side of that picture, that whole stretch of clouds along the right side of that picture is all one great big cumulonimbus cloud. Okay? So they are huge compared to other clouds. And while altocumulus clouds might warn you that a storm is coming, cumulonimbus clouds mean that the storm has arrived. It is here now. So, now that we've learned the different types of clouds, and we've learned that cumulonimbus clouds mean a thunderstorm is here, let's look at how those thunderstorms or those great big cumulonimbus clouds develop by going through the life cycle of a thunderstorm. So you have three pictures. The first one looks like this, okay? And this is the cumulus stage, because at this point, this cloud is not a cumulonimbus cloud yet. It's just a regular cumulus cloud, okay? It's not super huge. It's just a low-lying cumulus cloud, okay? This forms when we have a large bubble of warm, moist air that moves upward, okay? And usually, we need it to move upward quickly in order for clouds of this size to form. And the reason large bubbles of warm air move quickly upwards is because cold air is rushing in to take its place. Because remember, cold air is denser than warm air, so it's going to squeeze in under it, and it's going to force that warm air to move upwards quickly. The temperature in the bubble is going to be higher than any of the air around that bubble. So as it's pushed up, it forms this cloud. But as of right now, we have no lightning, no tornadoes, no severe weather that's associated with this. If there's any rain that falls from the cloud during this stage, it'll be spotty and light. The rising air can reach speeds of up to 160 kilometers per hour, which is pretty fast considering cars on the road usually drive in the 70 to 80 kilometer per hour range. Okay? It's 160 kilometers per hour is fast. Okay? And that's because all that cold air is pushing it up. So it's moving very quickly up into the air. All right. Next, we have what we call the mature stage. Okay? So at this point, we have clouds that have formed that extend way upwards, and they take on that characteristic anvil shape. See how the top pushes out and the bottom pushes out, and we have that curving anvil shape there, okay? This is when we start to get strong rains falling, so lots of heavy rain. And when that rain falls downwards, those drops of water knock into air molecules on their way down, and they start to create downdrafts, which is just air that is moving down quickly. Okay, so we have air being pushed up quickly into this thunderstorm by the cold air sinking in below it, and then we have heavy rain falling, pulling air down with it, causing air to move quickly downward. So we quickly start to see these updrafts and downdrafts formed inside the storm. Coincidentally, those up and down drafts are what cause hail to form inside of the thunderstorm. Okay? Air moving upwards now has a maximum speed of 300 kilometers per hour. So before we were going 160 kilometers per hour, we've now essentially doubled that. It's going twice as fast as it was before. And they can reach a maximum height of 25 kilometers off the ground. So they're going quite a ways up. Meaning about 5 kilometers is roughly 3 miles. So we're quite a ways up into the sky now. Big, tall storms. Okay. That upward moving air is still warmer than the outside air, but the downward moving air is now much cooler than the rest of the storm. This produces lightning, it produces hail, and sometimes it produces tornadoes. Those have lightning and tornadoes have stars next to them because we're going to talk about them at the very end when we're done talking about the thunderstorm. Okay? So this is when you start to see that severe weather happening. Now, after this, that's true. Airplanes do fly up in that height range. And you'll notice that they don't like to fly through thunderstorms, not just because of the lightning, which is an obvious issue, but because those downdrafts are strong enough to ground an airplane if you drive through the wrong one. So they tend to go around them. Now that we have, this is when you're experiencing most of that severe weather, then we have the final stage, which is called the dissipative stage. Dissipating means basically petering out and going away. So at this stage, all the air inside the storm has now cooled down. So its source of energy for creating all of that is gone. And there's now only air moving downwards. The air is no longer moving upwards. So the storm is going to start to split into disorganized bands of clouds at different altitudes, and it's just going to wear itself out. However, these stages, right, your maturing state, your cumulus stage, your mature stage, and your dissipative stage can happen nearby to each other. So you can have one thunderhead that is in the dissipative stage and right next to it another one that's just getting into the mature stage, which is why thunderstorms can last for, a couple of hours. If you just had one big cumulonimbus cloud, it might not last that long, but they often form in bands. So you can experience this kind of severe weather over the course of several hours, sometimes even a whole night or a day, where you experience these big, heavy thunderstorms. All right, now let's talk about lightning and tornadoes. So lightning, they don't fully understand how lightning forms, okay? But we do know this. Lightning is formed when static charges build up. So what happens is through some process, the bottom of the cloud becomes negatively charged, negative charges build up there, and the top of the cloud becomes positively charged. Okay? They think it has to do with hail and rain bumping around in there and dragging charges all over the place, but they're not 100% certain about it. Okay? But that's our best theory right now. So these charges build up. The bottom of the cloud is now negatively charged, and it starts to attract the positive charges that are on the ground. Okay? And when those charges build up to enough of a point that the pull from those negatives is strong enough, then we get lightning, which is essentially electricity flowing from the negative to the positive. And it happens very quickly, and it can happen between the cloud and the ground, between the cloud and an object, or between clouds. So this process can happen inside of the thunderstorm, or it can happen from the thunderstorm to the surface of the earth. Lightning is very powerful and very destructive, so you have to be cautious of it. Because lightning is looking for the easiest path to the ground, if you're caught out in a storm and you're worried about lightning, your best option is to get yourself as low as possible, because that lightning is looking for the fastest path to the ground, so it's going to find the nearest tall object to strike, and then it will make its way to the ground that way. So if you can make yourself as small as possible, as low to the ground as possible, your chances of being hit by it are much slimmer. And then we have tornadoes. Tornadoes are winds that are rotating rapidly around an area of low pressure. Okay? Wind speeds in that can be as low as 150 kilometers per hour, which isn't particularly low, right? So that's the low end for a tornado, is 150 kilometers per hour. Or they can get as high as 400 kilometers per hour. Because of the way that they rotate and the speed at which they move, they can cause massive damages. And they are spawned when thunderstorms start to create areas of rotating winds around low pressure zones. So they happen during severe weather. And we happen to live in Tornado Alley, so I'm sure you guys are familiar with the damage that tornadoes can cause. So this is where our notes stop.